Now see a perfect gas equation, PV is equal to mu RT, where mu is number of moles of the gas, R is NaKb, that is a universal constant, that is called gas constant. So now we can calculate the value of R from here. So we can calculate here R is equal to PV upon mu T. Mu is equal to, we can take here 1 mole. Now at STP, standard temperature and pressure, temperature is actually here 273.15 Kelvin, pressure is equal to 1 atmosphere, that is equal to 0.76 meter of Hg column, that is at pressure, that is a standard pressure. Now we can calculate it here, 0.76 into 13.6 into 10 raised to power 3 kg per meter cube, that is the density of mercury, into 9.8 Newton per meter square. This is the standard pressure. Now we know the pressure and volume, we can, this is your 22.4 liters. So 22.4 liters can be written 22.4 into 10 raised to power minus 3 per meter cube. If you put all these values in this equation, so you will be getting here R is equal to 0.76 into 13.6 into 10 raised to power 3 into 9.8 into 22.4 into 10 raised to power minus 3 divided by 273.15. If you put all these values and solve it, you will be getting here R is equal to 8.31 joule per mole Kelvin. So this is the value of gas constant at STP. Now see here, we have done perfect gas equation, that is PV is equal to mu RT, where mu is number of moles. It means PV upon mu T is equal to R. We know it, R is constant and its value we have calculated here just now. So PV upon mu T is constant. So when the graph is plotted between this PV upon mu T and pressure, we will see here there is a straight line here. So ideal gas, for the ideal gas, this straight line is obtained here, this graph. But if you plot the same graph for the real gases, you will be at the different temperatures. You will be getting like this is your T1, for T1 this, T2 and T3. Here T1 is greater than T2 is greater than T3. So from the graph it is clear that at low pressure and high temperature, real gases approaches the behavior of ideal gases. You know, because in this condition, it means at low pressure and high temperature, gas molecules are very far apart and there is no interaction between the molecules. It means the interaction between the molecules is equal to 0. That is the condition for an ideal gas. There should not be any interaction between the molecules. So all the real gases, they approach the behavior of ideal gas at low pressure and high temperature.